Hey again guys, and welcome back. In my previous video I showed you how to easily use these PIR sensors by working out my own personal kinks. So we've learned that you should probably stabilize the voltage rail on it with a capacitor or just use super clean power like batteries. Um, we've played with sensitivity and time delay, and also noticed that there is a sort of a delay before it can re-trigger again unless it's currently triggering, in which case you can set this jumper here to make it constantly re-trigger. So that's all well and good, but this is only the functioning principles. We still want to make this actually work. So you're not supposed to trigger or run a load directly off of the signal pin of this guy because it's not actually driven all that hard. So I want to take the signal, which is this guy, the white one in the middle here, and I'm going to run it through a NPN transistor. This is just a 2N3904 NPN, just a standard NPN transistor you can get just about anywhere. And I want to use this to run our load. This is a much better thing to do than to run it directly off of here. And on top of that, we know that if we run a load that's too large or too inductive-y or anything like that and sends noise up this line, you could actually re-trigger the device. Okay, so on the 3904 facing this way, flat facing me, it is emitter base collector. So the emitter will take the negative side of our load. The collector should be connected to ground. So I will put this one here to ground. Okay, and actually the base should be driven by a resistor. So I'll actually move this over here, and I will drive the base. This is a 1.7K resistor. I just happen to pick it up from my quick access box I have on the bench at all times. So this is brown green, so that is 1.5, sorry, not 1.7. So 1.5, then black, so 150, 150 times black. This is actually a 150 ohm resistor. Made a mistake there. I want something at least 1K, but not too huge. Let's see what we have in my quick access box here. So what do we have here? We've got brown, black. Looks like brown, black, black. That's a 100 ohm. Brown, black, black, black. That's no good. I want something at least 1K, I think. Brown, black, black. That's 100 times 10, 1K. So that's brown. Unless it's I'm reading it backwards, and maybe it's brown, green. Maybe that's another 150 ohm. Yeah, I think that's another 150 ohm. Uh-oh. Well then, I got a ton of these 1.3K ohm resistors. Certain values of resistors I ordered for projects, and when you order for projects, you just actually, let's grab a couple out of there. You just order extras, and plus resistors are $1 for 100, so if I need 10, I'll still order 100. There we go. So I got a bunch for the quick access box now. 1.3K. And one for my transistor. Okay, so let's check if it's actually 1.3K. Is that tan or is that orange? I think it's orange. So brown, orange, that's 1, 3. Black is 1, 3, 0. Red is 2 zeros, so 1, 3, 0. Or is that brown? That's brown. So 1, 0. 1, 3, 0, 0, 1.3K. There we go. Geez, that was more difficult than it really needed to be. So that goes into the base connection, which is the middle of the transistor. For those of you who like diagrams, here we have our PIR. Here we got plus 5 volts. Here we got ground. Here we have the signal. So signal goes through a 1.3K ohm resistor, like that. And then it'll go to the base of my NPN transistor. Like this. This one goes to ground. And that's 2N3904. And then here will be our load. And here will be 5 volts. So this is basically our diagram here. And the transistor is positioned here like it is there. The collector here goes back to ground. The emitter here will go to our load, so we still need to hook that up. And our resistor here is going to our base to our resistor to our PIR sensor. I'm hoping 5 volts will be enough to actually drive this thing, but it should be. Alright, so I'm going to stick this resistor. You know what? I'm going to back up this transistor one spot like that. I'm going to stick this resistor, this LED here, say about here. Okay, I need another male to male. Where are my wires? There's my wires. Grab another male to male. I'll use a different color so we're not too confused. So from the negative side of my LED to the emitter, like that. And then I need to give this LED power, so I will use a red from the power rail to the LED. And this is untested, as you can tell by the resistor not being in the right spot at the right time. I'm going to turn this on. I'm going to give the PIR a few seconds to just chill and stabilize. And let's see if we can trigger it. There, it's triggered. Turns off. It won't trigger now, but now it should be triggerable. There we go. Yep. Took a little bit. Yep, there's that 2.5 or 3 second delay. Give it a little bit of a wait again. And now I should be able to trigger it. Depends on the stability of our power supply. Yeah, it's not triggering. Just got to make double sure. That's to ground, our resistor to the base. Everything should be well. Yep. And if I keep moving, it'll stay on. Oh, it's not staying on. You know, everything goes super well when you're doing this on camera. Keep moving, keep moving. See, our LED is much brighter now too, because it's being pulled. It's given the 5 volts directly from our system instead of, I think, the 3.3 that this thing triggers on. And if I stop moving, it should turn off. And there we go. Working as expected. So now we can actually run several of these LEDs if we'd want to, because now we're going through a transistor, so everything is a little bit more stable. We can run, maybe 10 of these LEDs before we reach the current limit on our NPN transistor. But what if we want to run something a little bit bigger than that? Well, let's see. So I just reset the whole situation from before, but we're pretty much in the same sort of deal we had before. But now we want to run this LED. Now this LED, I'm going to plug it directly onto the 5-volt side of my breadboard. And as the most astute of you will notice, it doesn't light. Down here though, I've got 12 volts. And when I plug it in here, it most certainly lights. So that means I need to find a way to make this guy light this guy up. And I would call this a medium load. It will draw a little bit of current. You won't see it here because I'm actually taking it from the input of my power supply, so it will not be registered there. But the way I will do that is using one of these guys. This is a FQP30N06L. It is the same MOSFET that I've used for my kit here, 555 timer kit that I made with all the graffiti thanking my Patreons for their support. And so this guy here should be able to take this 3.3 volt signal and turn it into a switch for the 12 volts on here. So what we're doing is indeed extremely similar to this diagram here, but we're changing it a little bit. So here's the PIR still, and this is still 5 volts. This is still ground, and this is still SIG. Okay, now the MOSFET doesn't really flow current through its base or its gate. On a MOSFET, it's a gate, not a base. So we don't really need a resistor here. It might be a good idea, but we don't need one. I'm going to omit it for this, but if you're making one, okay, you can put any resistor here, like a 5K or a 10K or even the 1.3K, just to be safe is a pretty good idea. And then that is our transistor. In this case, it is a MOSFET. Okay, and then we want the drain and source. So on this side will be the drain, and on this side will be the source. So this is a FQP30N06L. And here we will have our load. So this will be actually a LED load. But here we'll have plus 12 volts, and here we'll have ground, and it can and will and may be the same ground as the other side. We can link the two grounds together. That's not a problem. So this should work. So this, as long as for this specific model, the signal is higher than 2.5 volts, which it is. It should be 3.3. It'll turn on this MOSFET and allow us to control up to 30 volts or 60 volts, is it? And up to, I think it's 6 amps or something. I'd have to look at the data sheet again. So the important thing is when you pick your MOSFET, you need a logic level MOSFET. You need a MOSFET that at the signal voltage will be fully on. So this one's 3.3. This one starts conducting at 1 volt and finishes like it's fully on at 2.5 volts. The other thing you have to watch out, this module probably has it built in, but it'd be a really good idea to put a resistor, like a huge resistor, we're talking about 10K plus, to ground, because if this is not definitively on or off, if it's left floating, this MOSFET could stay on. So let's hope that's not the case, but if so, we'll just fix it with a resistor up here. But yeah, very, very simple, and I will show you how it's done right now. So here we got my PIR right off the screen there. Okay, so here's our gate, and our gate on this MOSFET is all the way at the end. So it's gate, drain, and source. So gate, I'll plug that in there. So right now, I should actually just turn this off while I do this. And I should probably take the metal bits from underneath there too. That would be a good idea. Okay, so now you want the positive. So just like our diagram here, we want the plus 12 volts going into our load. So that's here. And we'll take the negative side of our load and put it in the drain. Okay, and then the source, we can bring it to any negative, but what I'll do is I'll take the source here and I'll put it in the negative there, but I will also link the grounds together. So that is ground, just making 100% sure, because this is not current limited to ground, like that. And I think this will be it, and this will also tell us if we need to put a pull up or pull down resistor on our MOSFET gate, but I don't think so. I think this should be fine. Alright, so let's try this. Press OK. It's on dimly. Don't forget, this thing needs a few seconds or a few minutes to settle down. So I'm not sure if this will be active right off the bat, but let's try to trigger it. Nope, it's not ready yet. Give it a moment. Oh, see, it's flashing on off. They do say in the instructions for this thing that it may flash on or off for the first little while before it stabilizes. Let's try it now. Yeah, it seems to be ready. Well, maybe not. Maybe not ready yet. I have to wait that 2.5 or 5 seconds or whatever it is in between. Yeah, not too bad. Not too bad. Seems to be working, although it doesn't seem to be driving it as hard as I'd like it to, because this is not super bright. We might be losing some current somewhere. Could be these crappy wires. It could be these crappy wires too. They're absolutely minuscule. Yeah, it seems to be working. I'm not sure if this is being driven as hard as it should be though. Let's put the 1.3k ohm resistor in between the gate and the signal. So I'm going to put the gate there and put this guy in there. Yeah, we seem to be dropping a bit of voltage here. This, in principle, this should be working. I'm going to give this a second to stabilize, and I will bring you guys right back. I am back, and this is stabilized, and it is working. However, when it works, you'll see we're dropping 1.663 volts across the MOSFET, and the reason for that is these LEDs are actually leaking some of the 12 volts through them, bringing the drain up to 3.6 volts positive, and this little 3.3 volt trigger is actually not bringing the MOSFET up high enough to open fully compared to that. And so actually the ideal would be to run the gate of the MOSFET here, this one, here instead of the load. So run the gate of the MOSFET here and still use a transistor to run it. So basically you would need a couple cents extra pieces. You would need your transistor still, and then you could run this MOSFET just like you would run the LED in the previous example, and it would be running just fine. But if you're okay with this dropping 12 volts instead of 10 volts instead of 12 volts, then this is still works just fine as well. But what if you want a much larger load? A load that's big and maybe even AC, like uses wall power. What the heck would you do in that case? Well, I've got that situation covered as well. So we are back to a blank canvas. So we're back to just the basics, 5 volts ground, our capacitor to stabilize, and our trigger output is there. To run a large load, you would need something like this. This is a relay. Relay is just an electromechanical device. It is really nothing special. All it is a switch. You've got 3 terminals here, so 2 terminals will be connected together normally, and then when it switches, then one of the terminals will go connect to the other one, and the other one will be disconnected altogether. So 2 of these contacts are normally open, the other 2 are normally closed. Which ones are which, I'm not sure, but I think the middle one is the common, and then whatever it's connected to will be the normally closed contact. But these things are amazing. They have a transistor built in, a resistor built in, a diode built in, and that's it. You feed it 5 volts, a ground, and you feed it a signal, and when the signal goes high, this thing clicks over. So this thing will be super simple. I'm actually going to take my signal off here. I'm going to replace that wire with a female to female, and I'll keep the color consistent so you can follow along. So this is actually the simplest of all the circuits, because this is like clicking 2 modules together, really. That's all it is. Okay. Take this white here and we'll follow the same theme. So that will go on the S for signal, like that. Then we need another red for positive, and this one, the positive, is the middle. So we're going to grab the positive from here, put it on here. Still in frame, just barely. Look at me with the videography. And we need another black wire to signify the negative. Just a little bit easier, I think, when you use conventional colors. There we go. Okay, now all this does is it'll swap between these 2 contacts. I'm not sure if this will work, but I mean it should. I'm going to turn this on. And already, you heard that? Went on and off like that. That means it's already working. Not sure if the PIR needs to stabilize again. I think we should be able to trigger it soon. And basically what it is 2 of these contacts are connected to each other, and then when you toggle the relay, it toggles which 2 are connected together. So here I have a continuity check on my multimeter. I just have the uni-t UT210E because it just happens to be on hand. These are the wires I was using earlier for my power supply, but don't seem to be working. Anyways, you see these 2 are connected. So what I'll do here is I'll just touch. These working? Yeah. Touch these 2. Yeah, these 2 are connected and these 2 not. And if I trigger this, the LED turns on, and these 2 will be connected then. So now all I need to do is connect my positive 12 volts, okay, to my LED here. This is clicking away, but that's fine. So positive 12 volts to the LED. this wire here will go into, let's say, the common in the middle here. It's great that we can do this while the PIR is stabilizing. Oops. You can buy these for about $1 each on eBay. If you just go look for relay module, there'll be tons of them available. I buy them 10 at a time because you never know when you're going to need relays. I'm not sure if I can actually get this wire in. This is like the thinnest wire I've ever seen. I feel like they're almost using it as a fuse. Okay, there we go. That's in. Okay, and now I just need one more wire, and one of these is the iffy wires. I'm going to give it a shot anyways. Okay, got to open this up. Stick this guy in. They have standoff holes and everything. These modules are amazing for the price. And then head to ground. Nothing. I'm expecting nothing to happen yet until I trigger the module. I'm going to try my best to not trigger the module until I want to trigger the module. Alright, so this is off. Don't need this anymore. Now, if we trigger this module, it should turn on the LED. So let's see what happens. There we go. And we get full brightness out of this LED because literally this relay is nothing but a switch. That's it. It's just a switch. So you can plug your AC devices in if you want, although be careful if you're not comfortable with the high, 100 volts, 200 volts. Then don't even bother, but this is just a switch. I can probably keep my hand waving in front there, and that light will stay on, and as soon as I stop, it'll turn itself off, and there we go. So we've got adjustable sensitivity and time, and we can run loads as large as we want. This one here will max out at 10 amps at 30 volts DC, or 10 amps at 250 volts AC. So pretty cool. Like, these little PIR modules by themselves are not too special, but once you incorporate them with some loads, you can see that they're a very powerful device. But I think that's it for today. I think I've got enough information gathered to make my project work, and so look out in the next few days, hopefully before Halloween. My project should have a video. Thanks again for watching.